Okay, so we're gonna start where we left off yesterday. We're still solving exponential equations, so we're solving for the exponent, right? And we talked about that yesterday, and we said that anytime I want to solve for an exponent, I'm gonna try to make both sides with the same base, right? The left side, the right side have the same base. Then I can make my exponents equal. All right? So if I have 3 to the power of 2x minus 4 equals to 81, I want to make that 81 as the same base as this 3. Right? So I have to find out 3 to the power of what gives me 81. Did you guys find what? Yes. 3 to the power of what equals to 81?
3 to the power of 4.
Good. So 3 to the power of 4 equals to 81. So I force the bases to be the same, right? So I can drop the bases and I can keep my exponent. So that means 2x equals to 4. So now I can solve. It's easy, right? Moving the x's, moving the terms around. So I move the 4 to the other side. It becomes a plus 4. And then divide by 2, right? Which gives me x equals 4. That's an easy one, no? Oh. Now, if you want to check your work and if you want to make sure that your answer is correct, you just have to plug in that 4 in for x and make sure that what you're going to end up with on the left side is equal to 81. Okay? So if I do that, 3, just check my work, to the power of 2 times 4 minus 4. And that will be 3 to the power of 8 minus 4. So that's 3 to the power of 4. And then if I put 3 to the power of 4 on the calculator, that's going to give me 81. So that means my left side is equal to my right side, and that's my checkpoint. Okay? So you don't have to do that check. It's just for you, for your own purpose, to see if your answer is correct. Okay? Are we good with that?
Yes.
So here's where the question starts getting a little more complicated. Okay? So I have 3 to the power of 5x plus 8 equals to 27 to the power of x. So I've seen many of your solutions yesterday. You got to a point, but then you are missing something. And this was the common mistake that a lot of students do make. Okay? So a lot of you yesterday, they changed the 27 to the power of 3, yes? As 3 to the power of 3, yeah? Because 27 is 3 to the power of 3. I want to make it to the base of 3 because on the left side, I have a base of 3. But what did you guys miss? What are you missing? That power of x, right? So you did change the 27 to 3 to the power of 3, but you can't leave that power of x, right? So that has to stay right here, okay? So I have now 3 to the power of 3 to the power of x. What does my law say if I have power to the power? Multiply them. So that means, to simplify this, that's going to be 3 to the power of 5x plus 8 equal to 3 to the power of 3x. Okay? Now, what do I do?
Bases are the same.
Bases are the same. I can drop the bases, equal the exponent. So I have 5x plus 8 equals to 3x. Right? In this case, I have to move, if I can move the 5x over, so that becomes 3x minus 5x. So I have 8 equals negative 2x. What do? Divide by what? Negative 2. That cancels the negative 2 out, so you will be left with negative 4. Okay? So the different step here is that you have to make sure that you don't forget that exponent of x. Otherwise, your answer is going to be totally different.
Maya, what I did, I still got to negative 4.
Yeah,
What I did was I moved 2x over to
that's fine.
the left.
And move the 8 to the
I
left, to
moved
the right.
and
Yeah.
it
That's
became
okay.
a negative 8.
Yeah. That would work. Exactly the same thing. It depends on which way you want to move things. It should work out to the same. Are we good?
Yeah.
Okay, so let's look at that last question. Or I want to hear your insights on this. What do you guys want to do for this? So you want to multiply the exponent first? Let's get rid of the bracket.
Yeah.
Sure. Sure, we can do that.
Minus 8.
1 second. So that's 2x. A lot of you, again, when I was looking at your answers yesterday, you did multiply the 2 by the x, but you forgot to multiply it by the negative 4. Be careful there, right? I have the distributive property. Okay, now I have two bases. One is 4 and the other one is 8. Can I make any of them equal to the other?
Yes.
What is it?
2 to the power of 2 to the power of q.
So you're telling me that I can't make 8 as a 4 to the power of something,
Yeah.
right? I have to change both sides to the same base. So this is the first time that we've seen this, okay? We usually change one of the sides, one of the bases. In this case, I have to change both of them. So I have to change this 4 to add 2 to the power of 2, and then to the power of this whole thing. And I have to change that 8 to 2 to the power of 3, again to the power of 3x minus 2. Okay? So what happened here, that base got changed to 2 squared, and that base got changed to 2 cubed. So now I have the same base. Okay? Now, in this case, again, I have power to the power. So since I have power to the power, what do I do with my exponent? Multiply. So 2 times 2x minus 8. What do I get?
4x minus 16.
Again, remember that 2 has to multiply to both terms. So if I have 2 times 2x minus 8, right? So that 2 has to multiply into both terms. Okay? Same with that 3. It has to multiply to the 3x, and it has to multiply to the negative 2. I can't stress over how many students miss this, okay? They usually do multiply into one but not into the other, which is going to mess up the whole answer. Okay? Make sure that when you're multiplying your exponent, you're distributing. Okay? Now you see I have the same base, so I can drop the bases and make my equations, my exponent equal to each other. So 4x minus 16 equals to 9x minus 6. I'm going to move the 4x to the right, and I'm going to move the negative 6 to the left. Doesn't matter which way you move them, we should end up with the same answer if you do your signs correctly. So that's going to be negative 10 equals to 5x. Divide by 5. So x equals negative 2. Questions? If you are still not 100% sure about this, what I would recommend that you do, you've seen it, you've seen what we've done. I would recommend that write this down, same equation, same thing, write it down on a piece of paper, put your solution away, try it, and see where you're struggling, if you are or if you're not. Okay? So you're not doing something different, you're still doing the same question, but you are doing the steps by your own, like on your own.
Yeah, when you are explaining the tricky one, even the tricky one looks like easy ones.
That's why I want you guys to try things by yourself first, okay? Because when I do things on the board, right, it's gonna sound easy, but when you try it first and you know that it's hard, you pay more attention to it. Okay? All right, so, and don't forget, I have more experience in this, right? So that's why it sounds easier.
Even like when we are reading the question in quiz, it took us like minutes to understand.
It's the experience, right? And that's why homework is very important. The more experience, the more homework you do, the more practice. Okay? Like any other job in this world. Okay? And don't you, like I do teach this course like all the time. I teach it like this year I taught it 5 times, the same thing, right? But I do like to change my material. Like maybe this year I did not change a lot with this course, but I'm a person that doesn't like to keep the same questions because then I get bored, right? So I'm not a person that likes to do the same questions over and over and over again. All right, so let's read that next question. Cross-country skier forgets a mug of coffee and a muffin in a snowbank. Their temperatures in degrees Celsius after T minutes can be modeled by the formulas T coffee is equal to 81 times 3 to the power of negative 2T, and T of the muffin is equal to 27 times 3 to the power of negative 1. Determine when the coffee cools to the same temperature as the muffin. So just so you know, the capital T represents temperature, and the small t represents time in minutes. So what do we have? What do I have here? Temperature for the coffee, yeah, and temperature for the muffin. Okay, and I'm looking at determine when. So determine when means what? What am I solving for? Time. Determine when the coffee cools to the same temperature as the muffin. What does that mean? What does that mean? I'm looking for time when the temperatures are equal to each other. So this is where, like, reading the question maybe a couple times will get you the idea, okay? So I know that I'm looking for the same temperature, which means the temperature of the coffee is equal to the temperature of the muffin, okay? So this is where the problem is. This is where I have to start, okay? Now what's the equation for the temperature of the coffee? 81 times 3 to the power of negative 2, T. And the T muffin is 27 times 3 to the power of negative. I want to hear your thoughts on this. How would you solve this? Make the bases equal?
Yes.
Okay. What would be my base?
3.
So you want me to do what?
3 to the power of 4, 42.
Okay, so change 81 to 3 to the power of 4. Okay, I can do that because 3 to the power of 4 gives me 81. So that doesn't change. How about 27? Can I change it? 3 to the power of 3. And this is where it helps if you know your common ones, okay? The 2, at least 2 to the, up to 2 to the power of 6. It helps, right? If you know that 2 to the power of 2, so 4 to the power of 3 is 8, 2 to the power of 4 is 16. It helps you realize these things so you don't spend too much time guessing. And it also helps to know at least up to 3 to the power of 4. Okay? Now, why is this important here? What I did here is we changed everything to base of 3. Why is this good? Like, what makes it now? Same base. Same base.
So you can drop all the bases.
and use that.
We can do what? Drop all the bases? Before I drop the bases, what do I want to do? Yes. I want to simplify the left side and I want to simplify the right side so they have only one base. Okay? So if you look at this one, I have the same base and I'm multiplying. So what do I do with the exponent? Add them. So that's going to be base of 3. 4 plus negative 2, that's minus 2. Do we see that? Okay. For the right side, same thing. I'm going to have to add my exponent. So that's 3 plus minus 1. That's 3 minus 1. Now it looks like the first couple of questions that we've done. Okay? So drop the bases. Don't drop the bases if you have more than one on each side. Simplify first. Okay? So that would be 4 minus 2t equals to 2. Leave the minus 2t here. Move the 4 over. And that would give you t equals to 1 minute. Okay? So it's a word problem. You're therefore the temperature of the coffee will be the same as the temperature of the muffin after 1